Okay, so we started off, we have our table of values, and we have the independent variable in this column, the dependent variable in this column. So in this particular lab, that means that we're going to have volume in this column, and we're going, in the second column, we'll have our mass values. Okay. So once you start putting your values in, so let's do that. Next thing we got to do is plot the points. So starting with this first one, we have 42.0 milliliters. Well, you can see this is a situation where you're going to have to estimate between the 40 and the 50. So 42.0, let's say, would be somewhere around here. And then we go up to 41.6. So once again, we're going to have to do an estimate. Of course, the 0.6 doesn't really help us. In fact, what we really are going to have to do is round that up to 42, given what we have here on the graph. And we'll get right about here. You can see that if we had more blocks with finer divisions, we wouldn't have to estimate so much.
Right.
Now that we have the points plotted, and you would have some more that might look something like this, the next thing we have to do is determine what kind of pattern is there. Well, it appears that we have a line. So we can make the conclusion that there's a linear relationship between the mass and the volume. So for that reason, we would like to find out exactly what that relationship is by finding the slope of a line that we can draw from these points. But the line that we draw is not going to necessarily go through any of the points, let alone all of them. So we're going to be doing what's called a best fit line. At this point, you're trying to set your ruler. You're basically eyeballing it, trying to adjust the positioning of it so that you're creating kind of an average positioning of the line. So you'll see some points may turn out to be on the line. Some may be a little below it, some a little above it. So you're kind of trying to split the line, and you're doing this by, as you say, eyeballing it, kind of like you line up a putt in golf, in a sense. Then, this is where the pencil really comes in to be necessary, is that you now will go ahead and draw that line, which will look much better when you do it on your paper than that. All right, so that's sort of there, but yours, of course, should be really straight. And you also would like the line to be relatively thin. After you've done this and you take the ruler away, you really should look carefully at the line and decide if it's the right one, because sometimes it's not, and you should then erase it and try it again. Now, the next thing that you do to find a slope is you have to pick 2 points on the line. You would like to pick 2 points that are relatively far apart from each other, right? Because that will reduce the error when we do our calculations. But we also don't want to feel restricted to things like trying to go on a specific crosshair. I mean, sometimes it works out, you know, this is a pretty good spot here, so I'll go ahead and take it. Notice that I'm circling the point because I don't want to obscure it. I want to be able to see it really well. And in fact, then I'm going to go ahead and write the ordered pair for that point, which in this case then would be 10, 10. Then I'm going to pick a point up here. Now notice how I'm going to do is I'm going to pick this one right here. And I'm specifically looking at the position where the line crosses the 80 marking. Because I know for sure, since I'm specifically picking that point, that it's exactly at 80, because I've defined it that way. Okay? But now what that means is that I'm going to have to estimate the positioning of the y coordinate. And so at this point, you know, you might pick this as, say, 81, maybe 82. You can't use a decimal because of the fact that these numbers are going by 10. So you really can only read to the nearest whole number. So let's say I'm just going to go ahead and pick, let's pick 80. Let's pick 82 here. There, 82. Now, at this point, we employ the slope formula, which you guys hopefully remember is the rise, or delta y over the run, delta x, which would be in math y2 minus y1 over x2 minus x1.
Sorry, what's delta?
So this part from here to here represents your delta x, and then the vertical line represents your delta y, and you create the triangle that you've seen before. Okay, so now over here, let's do the actual calculation. So the slope of this line is going to be y2, so that's 82, minus the y1, which is 10. And we also really should put the units on here because these do represent physical quantities. So the units for the y or dependent variable are grams. Okay. We divide that then by the change in the volume. So we have 80, which is our x2, minus the 10. And these units are in milliliters. So now doing our calculation, we have 72 grams divided by 70 milliliters, and this is where we pull the calculator out. And we get 1.03, and our units following our division are grams over milliliters, and that is read as grams per milliliter, where the per always refers to a division, which also means a comparison. So what this really means is that every time we increased the volume of the water by one milliliter, the amount of mass increased by 1.03 grams. Just about one, approximately equal to 1 in this case. That's pretty cool. Finally, we can see that the slope, which has really been calculated as taking the mass divided by the volume, you might recall this as being the density of the material, which is calculated by taking the mass and dividing it by the volume. And your units will always be mass units divided by volume units. So that's why in this case, we end up with a value of density approximately equal to 1 gram per milliliter, which therefore is what we would refer to as the density of water. And the fact that the line is straight, and therefore the slope is the same no matter where you are on the line, means that the density of water is a property of water. It doesn't matter how much or how little water that you use, the density is always the same. No matter how, like given the fact that the number is 1, no matter how many milliliters of water you should have that same number of grams.
Let's take